Okay, thank you. Good morning, everyone. Thanks for joining today. Quick thanks to Ayrton and the team for getting this event together and for the invitation to present. Today, I'm just going to be talking to you about the journey that we undertook at JLR to create the personalisation system for our Jaguar and our Land Rover brands, and a system which is known in the marketplace today as Smart Settings. Before I get to the topic, I'll introduce myself. So my name is Alan Armstrong. I've been at Jaguar Land Rover for over 10 years and worked in engineering since I completed my degree back in 2002. At Jaguar Land Rover, I'm a technical strategy manager, which is known in our business as a technical specialist. And the strategy that I'm responsible for is the personalised user experience. So let's get started. So personalisation, the idea that a product performs in a unique way so that it's tailored for each unique customer who uses the product. But how does that translate to language which enables a solution to be engineered for a car? This was one challenge the JLR engineering team faced with the design and development of a personalisation system. And I'll tell you about how they resolved this challenge and what was developed as a result. Of course, they faced many other challenges, and we'll also have a look at how some of these were also overcome. So back in 2015, we set out on a project to create a great personalised experience for our customers. And we asked ourselves a common question at the start of any project, which is, what are the key factors which would define success? But this time, we found that answering this question wasn't quite as simple as usual, because the rules for defining success when developing a standard standalone feature didn't apply this time when developing a personalised experience. Let me explain what I mean. Personalisation isn't a feature, but it's a method of controlling various features to deliver an experience. So to figure out what success looked like, we considered what matters to people who were using technologies that were already personalized, things like phones, the internet, and online media services, for example. And using this approach, we uncovered an interesting trend. This insight that we uncovered was about the priorities of customers who use typical standalone features in a car, like a reversing camera, against the priorities of the engineers and developers of developing those typical standalone features, like a reversing camera. So, what do I mean by that? So this triangle here shows some key factors in product development to achieve customer satisfaction. And on the left of the triangle are some customer-centric factors typically related to the development of features such as maybe cruise control or power tailgate or Bluetooth phone connectivity. And these words are aligned to the levels in the pyramid based loosely on human-centered design principles. On the right of the triangle are the equivalent factors which an engineer or a developer considers important to do their job in an innovative way, to do their job efficiently, and to deliver a good quality solution. But in the case of developing the JLR personalized experience for our customers, we came to an interesting conclusion. And that is that some of the most defining a successful engineering solution were actually the same as those for defining a successful personalized customer experience. So this insight allowed us to conclude that the factors defining success for JLR's personalised user experience are automated, seamless, and clear. And with all the other factors on the right-hand side still relevant as implementation guidelines. So now the team had project definition and scope. I'm just going to look at those three kind of guiding virtues a bit more. So by seamless, we aim to create a system so the user typically experience less complexity and reduced workload compared to what would be experienced without personalization. By automated, we would strive to reduce the need for interaction and to manage tasks on behalf of individual customers, whoever that customer may be. And clear meant the customer easily understood why the system performed a certain automated operation and what state that system was in, or the feature was operating in. Now, this last point was especially relevant and challenging as automation implies the need for a system to operate passively or in the background without any explicit direction from a user. So because of this, we had a conflict of requirements between minimal intrusion to the user while also ensuring the customer was always informed and in control of the automation system and features. And I'll come back to this point later and look at how we resolve this paradox. So with the scope and the definition of a success now defined, the team could continue to engineer a solution for Jaguar Land Rover's personalisation system, which is known as smart settings. So to deliver the personalised experience, we settled on a system which decomposed or broke down into three high-level functions. And these are, excuse me. Sorry about that. So these three functions are automatic driver identification, so identifying the driver automatically and robustly, applying the driver settings quickly so that the car is ready for the individual user to get in, and learn how the driver uses the various features in the car over time and then automates the use of those features to reduce the workload. Now, to deliver a premium solution that was best in class, we found that each of these functions posed unique challenges that the team needed to overcome. So for driver identification, we developed and patented a two-stage process involving both the key and the phone. So the key is used to the key that's used to unlock the car is in effect used to load the profile, and then the phone becomes involved later on to basically ensure that the settings are saved. To contribute to a premium personalized experience, this function also needed to be highly robust and resilient to typical noise factors. Now, one such noise factor was the shared key use case. So let's suppose I lend you my key and that the car applies the settings based on the key which is used to unlock the car, my key. You get in and find that the car isn't right for you at all. Why would it be when my settings have just been applied? So you begin moving the seat and the door mirror positions before setting off on your drive. Before long, you realize the aircon temperature is too low, so you change that, while also setting the ambient lights to a different setting while you're waiting at some traffic lights. Later that day, I see you again and get my keys back. When I return to my car and unlock it, I get in to find most of my settings are all wrong. And this is one of the big problems with a key-only solution to identifying the driver of a car. So to negate this problem, we decided to develop a two-stage system where the key is used to load the settings quickly before the driver is in their seat. Then a second identifier, such as a phone, which connects through to the Bluetooth system, is used to confirm that the loaded profile is correct based on what was loaded from the key. So the JLR personalization system, based on two-device identification, allowed the team to create a solution that was quick to identify the user and robust to a common problem use case. And this allowed us to deal with the first major use case challenge that we faced in developing the premium personalized experience. The second of the three functions needed to deliver that personalized experience is settings management. Now, this is probably the most invisible and intuitive of the functions we developed. It means configuring the settings and preferences for the individual who is driving the car. The settings to be loaded could be defined by the automatic driver identification function using the key and phone that we've considered, or via manual selection of a profile from a menu in the touchscreen. To configure settings and preferences, the system first needs to remember the settings and preferences. And this is a challenge when dealing with over 280 different systems and functions that can be configured. Excuse me. And between these 280 different functional areas, there are literally thousands of possible settings to have to save and also for the system to recall quickly. Now, consider that the settings need to be remembered from, like I said, many different disparate function areas, from HVAC to infotainment, from instrument cluster settings to head-up display configurations, and from seat positions to driving dynamic configurations. So this posed the team with a very difficult integration challenge. And this challenge was further complicated because the solution had to provide an efficient and robust method of implementing not only the first instance of settings management on the system, but also be easily scalable and adaptable to keep pace with the never-ending proliferation of features being introduced on our cars, with more associated settings to manage, but also, of course, the different types of settings that you experience on the different cars within our product ranges for each of our two brands as well. Now, I'm sure that anyone who's listening to me today who's worked in the automotive industry on projects with more than 2 or 3 stakeholders will testify that this type of integration work is never easy. But despite the issues the team faced, they delivered an exceptionally efficient, robust, and highly scalable settings management system. And this really is now the backbone of not only the current, but also the future JLR personalization systems that we'll be developing. So the last piece of the puzzle to complete the personalized experience was self-learning car. This function monitors how the driver uses various features, such as the heated or the cooled seats, which phone numbers they dial, and which media sources they activate during each journey. This data is then fed into machine learning algorithms to allow the system to find patterns and relationships in the data for each individual user. The discovered patterns are then used to make predictions to automate various features, leading to a bespoke experience for each individual driver for each individual journey they make. So let's look at an example of this. Would be activating the heated seats. Imagine you get into your car on a cold day and begin your journey. Very early in the trip, your back gets cold, so you decide to turn on your heated seats to the maximum heat setting. After a few minutes, you've warmed up and the cabin is also warmer, so you turn the seat heater down to a lower level, and then you leave it at this low level for the rest of your journey. The self-learning car system monitors this heated seat usage behavior along with other information available, such as temperature, the time, the date, etc. All of this information is then processed by a machine learning algorithm to learn not only how long the heated seat is active and at what level of heating, but also what the context is, such as the temperature and the time of day for that specific pattern of usage for that individual. To create such a feature that learns the behavioral patterns of an individual customer and then also continually adapts to any changes in that customer's behavior meant the engineers at JLR had to master machine learning techniques and also data analytics skills. They had to become data scientists and also implementers of AI systems. And at that time, there was very little support available to them in the automotive sector. The systems engineers within the team had to think creatively to design and develop a framework which would robustly host the machine learning software functions on a vehicle architecture, so a vehicle electrical architecture that was dedicated towards, it was highly refined to supporting more traditional procedural automotive functionality, not machine learning based functionality. We also found testing was a real challenge at the customer level and also at testing to verify the implementation at the software level. And this was because, unlike typical procedural systems, which are developed and tested and then signed off, a machine learning system continually adapts, and there are an almost infinite number of possible test cases which clearly can't all be tested. And of course, this problem applies not only at the low level, but also at the customer level. So to overcome the challenge of testing this system, a number of innovative solutions were developed, including the use of concept solutions being used on fleets of cars to obtain user feedback as the features matured and the machine learning data set matured over time. And in terms of testing the software implementation at the low level, a wide range of automated test methods were also deployed, some of them using pseudo-random data to be generated. And this was done to test the boundaries of the machine learning systems that were being defined and developed. Another challenge I'd like to share with you relates to the HMI that we developed. I'm sure you can all appreciate that the system we've created is fundamentally passive in nature. It's meant to automate to reduce the interaction needed by the driver. But the interface with the user still had to ensure that they were in control and that they were informed what the state of this somewhat ethereal AI system was actually in. So to do this, we developed a feature, a status mechanism, which had 4 distinct states. The default is learning as opposed to off. And this is because if the default was off, it would mean that the system would not necessarily learn customer behaviors by default. So this would not initiate any customer interaction with the user, which is kind of the whole point of an automation-based system. In the learning state, the system monitors how the user interacts with a feature, such as climate seats or the media player, and attempts to identify usage patterns. And this is all done passively without the user having to do anything that they wouldn't normally do in using the car. Once the system has robustly identified a pattern, the system then transitions from the learning state into the available state. And at this point, the driver is notified that a particular feature is now ready to be automated based on some machine learning analysis of their patterns. If the user authorizes the system to begin automating the feature, then the system would switch from the available state to the active state. And from this point onward, the system will automatically activate the feature when the machine learning algorithm is able to do so based on the analysis of the previous patterns and also, of course, the situation for which a prediction is needed for this particular drive cycle or journey. So in August 2018, Jaguar Land Rover was the first to market with a personalisation system that not only remembered the last settings of an individual vehicle user, but also learned the usage patterns of numerous features and resolved the problem of sharing a key. The HMI user icon in the bottom left corner of the HMI main touchscreen is used to indicate which user profile is active at any one time for the driver, and a welcome message is displayed to clearly indicate to the user that they have been identified by the system. The icon in the bottom corner, the green kind of circle icon, this is also used to indicate to the driver when a feature has become available to be automated by a small icon appearing over the top of their personalisation avatar. The raft of self-learning car features are all provided as part of Jaguar Land Rover's personalisation to learn user behaviour and automate feature activation. And that also includes the mode of activation and also the duration, so that you can see the 7 features that we've developed for our customers today. So doing this piece of work, it was challenging. It was also highly rewarding for myself and all the other engineers in the teams at JLR who were involved in developing our smart setting solution. I think everyone in the team developed many new skills and challenged many of the methods used to develop typical automotive features because we simply didn't have the skills and the tool sets available to us in automotive industry to develop this a few years ago. But in doing this, the team have developed an excellent skills base in-house, which has prepared us for many more exciting personalised AI-based personalisation feature developments in future. So finally, I'm just going to play a short video about the result of all of this hard work. It's Jaguar Land Rover's smart settings. Okay, that's all for myself. I'm happy to take any questions.
Okay, thanks, Alan, for your presentation, for giving us all these insights. And we are happy now, to forward your questions to Alan. For the Q&A, I would hand over to Leonie.
Thank you. So let's jump right in. The first question we have here, how did you choose the machine learning algorithms for the self-learning car?
Okay, so what we did was we involved the research team at Jaguar Land Rover, and they've already had some experience in looking at machine learning techniques. So they were heavily involved in doing a lot of the data gathering and also the data analytics to select which algorithm was the most suitable to find the patterns to help us automate the different features on the car.
Thank you. And then let's jump to the next question. How do you see personalization of vehicles developing in the future?
Massively, I think I think as we're all aware that there are many companies like Uber and Waymo getting involved in automating in basically moving people around and transport services, and these kind of companies have access to even more data than some of the more traditional automotive manufacturers. There's also the introduction of autonomous cars and autonomous driving, and I think one thing that the autonomous car gives the user is time. It gives them back time when they're not having to drive, and I think in future we'll see the cabin system having to be far more adaptive and responsive to individual users of the car than is today, to help them make the most out of the time that they've got back while they're in the car. And I think I'll be talking a bit more about this generally at the HMI Europe conference in a few months' time.
Good, thank you. And do you have any guidelines or policies to build the intelligence for the car?
Yes, we do. There are a number of parties that we work with, some of them in academia, because again, I think when you're developing machine learning solutions, you've got to consider things like bias of data and transparency, and making sure that the system is resilient to problems like poor data or missing data. So there are some frameworks which don't only apply to automotive, but apply to generally to the use of machine learning and AI solutions.
Mm-hmm. And have you received already any user feedback for the self-learning function?
We have. It's been very positive. I think some people are not used to this concept of a feature not being kind of available on demand straight away. The system does have to learn for an individual user. That can take some time, depending on how often the customer uses their car, how long some of their journeys are as well, and how often they use the features, of course, in the car. So, but when people do start getting the system reporting that a feature is available, and then subsequently when they do get some of the automatic operation features, it's generally seen as a very kind of delightful experience, something that's very novel in automotive.
Okay, and how did you resolve multiple passengers, multiple phones, and multiple key fob in the car?
We haven't yet. That's our next offering. So it's coming to a Jaguar Land Rover product near you in the coming years.
Okay, then that's a question to be answered in the future. And how did you do usability tests for the self-learning function?
Yeah, so good question. like I mentioned it very briefly, that this was a big challenge to try and develop and engineer in parallel with with understanding what the impact of the engineering changes was on a wide range of individuals. Because, like we said before, this is not a procedural solution. You can't make an engineering change and then simply test it with one or two people, because machine learning reacts differently to different people. So we basically worked extensively with the in-house research team at JLR, who we would develop the solutions, both the identification, settings management, and the machine learning-based solutions, and then we would in effect push the developments back out to a set of trials being run by the research team with many participants, and use the feedback again from those updated system trials to then push back into the development process, being managed by engineering.
Okay, and can you provide us with an example of a learning that maybe surprised you or that you did not expect?
Yeah, there was a few. I think one of the situations that kind of tripped us up a little bit was around predicting the start times of journeys. So one of the patterns that we uncovered was that people start their journeys at very different times, but within a window. So some days you might set off to work at, say, 7:30, other days at 7:45, and other days at 8:06. So they are different, and they could actually have connotations. So if you set off a few minutes earlier, you might actually be driving to the shops or the school before going to work, whereas if you set off at a slightly different time, you might be setting off to drive directly to work. And of course, journey start time is quite an important piece of information for machine learning-based solutions, because if it's gathered robustly, it can be a fairly useful piece of information to base machine learning algorithms from. So yeah, that was one challenging solution, to basically find robust ways of determining what a journey start time would actually mean in terms of patterns of users.
And what parameters do you consider before developing new features which don't exist anywhere else yet?
Well, I'm not quite sure what that means. I think if you mean by machine learning parameters or features, then again, it's the research team heavily involved in doing a lot of data mining and data crunching to actually extract the patterns or the signal in the noise, as it were, to understand not only which features were the most relevant, but also which machine learning algorithms were the right ones to obtain those features. I suppose if you mean by feature development from what's available on a car to control and automate, then again, there was a lot of human factors work involved to basically say, out of the many tens or even hundreds of different opportunities, which ones are the most desirable, valuable, and actually achievable as well from a machine learning and personalisation standpoint.
Mm-hmm. And then the next question, I think that relates to the previous one of having findings that you might not expect. Did this at JLR change any organizational or internal processes?
I think, like most companies, the organisation processes is changing continuously to try and keep pace with the rate that the automotive sector is changing, month by month almost sometimes. So I think yes, but more as a case of opportunistically with how fast automotive is changing with case or ACEs, whichever one you look at as being the fundamental drivers to what's happening to automotive in general.